So our second topic for this morning is for digital frontier track is binary GPT, leveraging generative AI for binary and malware analysis. So let me introduce our speaker. So Ahmed is a security threat research engineer with over 8 years of experience in cybersecurity. He specializes in malware analysis, reverse engineering, and automation. He also conducts in-depth malware analysis, developed robust threat detection strategies, and significantly contributed to the field through published research and patented technologies. So without further ado, I won't keep you guys waiting. All Ahmed.
Thank you. Good morning, everyone. Thank you all for being here today. Actually, today, first of all, my name is Ahmed Ibrahim, as they introduced me, and I work as a malware researcher at Trend Micro right now. Today, we are going to explore how generative AI is transforming malware analysis and reverse engineering. Since the release of ChatGPT, we have seen an AI revolution where every company, every industry are trying to adapt AI technologies into their workflow. And malware analysis and reverse engineering are no exception. Today, I'm glad to introduce the first binary analysis platform powered with AI. I call it BinaryGPT. Before we dive in, okay, I would like to know how many of you work in malware analysis, incident response, SOC, or have to deal with malware some way or another. If you can just raise your hand. Okay. Actually, this is a good number. I think you will be related to what we are going to do because we experience the manual approach of malware analysis, and today we will be introducing the AI-driven approach. And for those who are less familiar with malware analysis, we will go through some background and comparison between the traditional approach and the AI-driven approach to make sure we're all in the same page. Okay? And actually, this is our agenda today. We will talk about this quick comparison, and we will go through an overview about BinaryGPT and its feature and how does it work. And we will show you some demos as a proof of concept of what we are introducing today. First thing, traditional malware analysis approach may be very time-consuming and very boring and require deep knowledge and expertise, okay? However, okay, mainly when you perform when you perform malware analysis, you have to do multiple stuff like static analysis, dynamic analysis, and so on. But today we will be focusing on advanced static analysis, okay? When you perform static advanced analysis, you have to start with some decompiling of your malware, okay? You have to decompile the malware or disassemble. And this step or this phase depends on the file format, the compiler, and it requires some knowledge about the reversing tool like IDAPRO, Ghidra, DNSPy, and so on. Then once you decompile the code, you have to understand what each function is doing. And you have to understand the logic behind the malware to build something like a report. Then if you are dealing with advanced malware, you have to handle some obfuscation, packing, encryption, and so on, which is very time consuming. It consumes lots of time to handle just obfuscation, okay? Then once you understand the basic knowledge of what this malware is doing, what the code logic, you break it down into small pieces, you have to map these functions and behavior to MITRE framework for a better understanding for the threat for everyone in the industry. Then you have to collect all these findings in one beautiful, comprehensive report, okay? This process is mainly time-consuming. However, BinaryGPT can speed up this process from decompiling to comprehensive analysis. Even it can handle some obfuscation cases, okay? Actually, time in cybersecurity is very crucial, okay? And our goal is always to minimize the time between identifying threat and the mitigation strategy or the protection that we deliver to the customer. In our lab, we have proven that BinaryGPT is 12 times faster than a human. And this is for sequential tasks. What I mean if we have a malware and we have a human being and BinaryGPT analyzing the same malware, if a human analyst can do it in 1 hour, BinaryGPT can do it in less than 5 minutes, okay? And we will see this in live demos, okay? Now, what is BinaryGPT, okay? BinaryGPT is an AI platform. It's a web application like VirusTotal, AnyRun, like all these applications that help individuals and researchers to analyze and reverse engineering binaries without no experience required. Because if you start analyzing a malware, you need some programming skills. Not everyone has it. If you work in a network side, you might not be that good in malware analysis or programming. So this is a challenge. But now you might wonder why we don't use just sandbox. Can anyone give me an insight why we can't use just a sandbox? Why do we need another platform like BinaryGPT to do that? Any ideas? You can just raise your hand or you just start to. Okay. Yes, please. What's your name?
Paul.
Nice to meet you.
Some malware samples have sandbox evasion techniques.
Amazing. Great.
It might not be plausible to just rely on sandbox. You have to rely on other sources.
True. That's amazing. Thank you so much. Actually, as he said, those sandboxes are generating the reports based on the behavior-based analysis. What does it mean? It means you have to execute the malware on a machine. While those sandboxes are very good, and I'm not saying sandboxes are not good, but what I'm saying, sandboxes alone are not enough, okay? Because as he mentioned, we have some malwares are some malware are using evasion techniques like anti-sandboxes, okay, which prevent the malware from fully executed on the sandbox, which lead to incomplete report. Imagine if I uploaded a malware to AnyRun or something like that, and this malware is using evasion techniques, I will get incomplete insights about what's going on, which could lead to a bad and the worst mitigation, because I don't have insight about what's going on. Okay. Second thing that we see right now, the misattribution. Okay. We see some misattribution, some sandboxes, some automated malware analysis platform are doing misattribution. So they can flag a malware as a stealer, but this malware is not a stealer, it's a ransomware. Okay? But because they are using automated system, okay, based on string analysis, based on ABI analysis, they do something like misattribution. Okay? However, unlike those sandboxes, we are generating based on the code level. And it doesn't require any experience. You just have the file, you upload it, it's done. Okay? BinaryGPT providing in details comprehensive insights about every single malware in every single function in the binary. Right now, we have only version 1 in production. It has been used by my team. And we support .NET malware. .NET is a huge market. It's easy to implement. We still see hundreds of malware every day developed in only .NET. So we are trying to cover all kind of implementation because it's not always straightforward. .NET, they have almost 6-7 types of implementation, okay? So we focus now on .NET, but we have plans to add more in the future. Now, what are the core functionality that we have? The first function is, the first feature is in-detail analysis. So we provide a comprehensive analysis of each function in the malware. So if I have a malware consists of 100 samples, you get the result in less than 5 minutes, okay? Second thing is generate out of this feature, because we can analyze each function, we can generate a real-time analysis report. You see the result in real time. So what is going on? Second by second, minute by minute. Then we map everything to MITRE, because this is one of the challenges, because as a human being, we don't remember every single MITRE technique. It's a huge framework. So you can't recognize everything, but AI is capable of doing that with no time. Then the fourth feature is we visualize the function in this malware in the following the execution sequence. So we are not just picking a function from the middle of the malware and show it at the beginning. No, we show the main, then the first function, the third function, and so on. And my last two features, my favorite features as of now, because we have a real pain in malware analysis industry dealing with obfuscation. if we are saying the traditional approach consume lots of time and it's time consuming, if you are dealing with obfuscated malware, it's a way more than time consuming than usual. So AI and BinaryGPT is able to de-obfuscate and beautify these obfuscated element, function name, classes, variable, and give it a human readable version. Out of this function, we can generate a new malware, human readable version of the malware, okay? So you can just facilitate the further analysis if you would like to do it manually. Okay, what is happening in the background, okay? For those who are familiar with malware analysis, they will relate to what I'm gonna say. First thing, BinaryGPT, when you upload a file, a malware, to BinaryGPT, first thing that we do, we break it down into small pieces, okay? And we build something like this. I'm not sure if you see it or not. Let me just try. Okay. So once you upload BinaryGPT, break the code, break the binary into small pieces, and in a small context. Then we create something we call context, okay? Context is we collect everything related to this one function, variables, anything, and we build this context, okay? Before I move forward, can anyone give me an idea about what is going on in one of those functions? Yeah. Any ideas? Okay, let's move forward, okay? Now, let's focus on the function here, this function, okay? First thing, we see some kind of file operation. We see we see write, we see read operation, okay? So we can build an assumption about what is going on, but it's not complete because we have some obfuscated name, okay? So what we are gonna do, BinaryGPT will take this function and send it to our language model, okay? Okay? Our language model will do all the heavy work for us. It will go through this function, not this function, it will go through the context that we built about this function, and he will start giving us a quick description about what is going on, okay? If I zoom in right now, this is the description, okay? So we see that our language model has decided this function and he gave it a name as initial configuration. And this function contains some system information gathering and some stuff like DNS resolving, okay? But still, no one can prove it, okay? We don't know what is going on. Okay, this is a beautiful description, but the function is not clear, okay? What are these stuff? Oh, sorry. What are these functions, okay? If you see, I'm highlighting right now. What are these functions? Nobody knows how this description came out of something that is not human readable, okay? This is the second feature that we have. We have this beautification feature. See what is going on right now? On the left-hand side of the window, okay, the original function we decompiled from the malware, okay? And on the right side here, after beautification, we get a very beautiful clean code that shows that there's a function called collect system information and a function called resolve domain to IP. So this function, this description came out of this function code after decompilation. Then I have a question for you. What do you think the MITRE attack technique we should attach to this code? Let me zoom in again. I just need it to be more interactive, okay? Just give a guess or something like that. What could you imagine that we can map this code to MITRE? Any ideas? I know that we don't remember MITRE techniques. It's fine. Just give a guess, give a suggestion about what's going on. Yes, please. What's your name? Sorry?
Hello.
Hello.
Collect system information.
Okay, what is the technique name?
I can't remember.
Okay, this is one of the human limitation. Like we all do that. What else do you think?
System info and network info. You said DNS
Amazing.
resolution.
What, do you have anyone? One more. Okay, there's one more technique.
There's the sandbox detection one.
Okay. Anyway, thank you so much. You got two. Okay. But eventually, we can just write a generic names like what he said. We have to map it to the real MITRE attack techniques. Okay. And we all have this limitation. Okay. I don't remember all MITRE techniques. I have been in industry for 10 years, 8 years. I don't remember all the techniques. Okay. But AI, in no time, has generated the MITRE attack techniques for us. And as he mentioned, there's some kind of system information discovery and some file directory and application due to the AI domain to IB resolving. So this is something we can do in no time. It can consume lots of time from a human analyst, but in no time we have the result. Right now, we will see the first demo. And in this first demo, we are analyzing a .NET to showcase the comprehensive analysis capability of BinaryGPT, okay? Mainly in this, I have two demos. First one is a relatively small malware, consists of 13 functions. May I know how many time it could take from a human analyst to analyze a binary consists of 13 function? Can you tell me? Just an average. You have to provide a beautiful report that contains all the information. 1 hour? 2 hour maximum, okay? So as our friend here mentioned, it could, for 13 function, which is relatively small malware, it could take 1 to 2 hour maximum, okay? And in this demo, BinaryGPT will do it in just 1 minute, okay? Let's play the demo, and I'm gonna explain while the demo is running. First thing, we download the malware from VirusTotal. First of all, if it's not clear, just let me know. I can zoom in if you are interested to see something, okay? We are gonna download the malware from VirusTotal, or you just can archive it as a zip, and you can upload it to BinaryGPT. BinaryGPT will display a very basic information about the malware, and we see some engine detection from VirusTotal with some misattribution. Some of the engine call it BinaryGPT, sorry. Some of the engine call it stealer, some of them calling Trojan, some of them calling ransomware, and this is the issue of misattribution, sorry. Okay. Second thing, I would like to mention that we didn't reverse this binary. We have no experience about what is going on. As you all see, we just downloaded, we uploaded, okay? So this is a basic, this is not an AI, okay? This is just basic information. The first thing that we get is the function tree, okay? Do you see it? So first thing, we have the main function here. We have the main, then we have some is running inside VM. This is the execution flow. The malware will be executed like this, okay? Then, this is the execution flow. And from the function name only, this is the value of the function name. I would like to mention that because we will need it in the next demo. From just the function name, okay, you can build an assumption about what the malware is doing, okay? We have some is GPU installed. We have two interesting functions here. One of them is Bing, and the other one is process response. We don't know what is going on, but I still can build a basic conclusion about what is going on, okay? But let's focus on those two functions, Bing and process response, okay? Let's resume. Now the real magic begins. Once you click analyze, we break it down, BinaryGPT break it down. We send, now our language model start returning our result, okay? So for every single function, In the execution flow sequence, we get the description, we get the code, we get what is going on, without any single reverse engineering experience required. Now I'm gonna pause at the ping function, because this is interesting, because when you work as a malware analyst or researcher, you have to come with some IOCs eventually to provide a protection to the customer, okay? And this is one of the IOCs that we have. Sorry. Okay. Okay. Now I'm gonna zoom in, and I would like one of my friends who works as malware analyst to tell me if this is something, is the description accurate or not? This is a function which do some C2 communication. It extracts some information to the C2 and download something. If you see the description, it is almost this, what I'm talking about, okay? Is it correct? Okay, let's move on. It's correct. Then we have the next demo. Let me move forward to the next demo quickly, because this is the most strongest function in BinaryGPT, okay? Now, in this demo, we are analyzing a malware that consists of 40 functions. It's a big malware, and it's very time consuming. If no obfuscations, I have to go through every single one of these 40 functions to figure out what's going on. But this malware is not straightforward. This malware is using obfuscation. They are using obfuscation for variable name, function name, classes, so it will take more time than usual to analyze this. It's like before, we get this basic information. Then we will figure out what are the functions from the function tree tab, okay? So once you click on the function tree tab, as you see right now, these are the function name. None of us have a clue about what is going on now, which will require us to go through every single function of this function, okay? But in less than 2 minutes, BinaryGPT will beautify these functions, okay? Which is a very time-saving advantage, okay? I'm gonna run it because we are almost running out of time. Now, this is the beautification. Let's start. We are beautifying our own malware, and we will just pick some random function to figure out what is going on. So, as you see here, we have the original function name, a quick description based on the code of this function, but we are not displaying it here because we are not interested in the code. We are interested in the name. Then our language model will return the suggested function name, okay? Here, if you see this function, it should check if remote debugger is present. So this is kind of a defense evasion anti-analysis technique, okay? We didn't recognize this from the first look, okay? But now with a beautiful name, we can recognize what is going on. This is an anti-analysis technique, okay? Let's continue. And here we see that the malware is do some system information gathering. And not only this, if you see, the AI decided which information the malware is collecting. So we see processor type, BIOS, and hardware-related information, and it gave it a very beautiful name, get system information. Okay, let's run it quickly. And I'm gonna pick one more function, and we are gonna finish. Okay, if you see this function here, remove restore point. Mainly, this is this kind of behavior we see in ransomware. Okay, so now we have a conclusion just based on the name. This is a kind of a stealer, and it's a ransomware. Okay, later on, the BinaryGPT was able to identify the encryption algorithm used in this malware and many more information. But we don't have time for this. But I'm gonna just show it right now. Okay. Uh, what can take this beautification stuff as a human being, as an analyst, it takes 3 hours just to beautify the malware, because eventually I'm gonna ship a report or a blog to the customer. It takes 3 hours to just do a boring task, just renaming, go through each single function. But in no time we have the function. And out of all of this, we are generating a new human readable version of the malware. Once it's finished, we will get this download button at the down left of the page, where it gives us an option to download the human readable version. And we will show a quick comparison between the two versions, the human readable one and the obfuscated one. Okay. Oh, sorry. Now we got this download option. We download the new file, and I'm gonna show just a quick comparison between the two versions to show the power of the beautification feature in BinaryGPT and to show the power of AI in malware analysis. On the left side window is the original sample. On the left side window is the renamed, the human readable version of the malware. Okay, and as you see here, let me zoom in. Okay, now we get some beautiful name, and in the execution flow, we have the main detect debugger. We have some check if remote debugger is present. This is the real value of AI. AI can save lots of time just in those kind of boring tasks, renaming, beautification, helping with obfuscation, and so on. What is next? We are trying, right now we focus on .NET binaries, okay, but we plan to add more file formats like file compiled binaries like C, C++, Go binaries. We also plan on enhancing our AI model. Right now we are using 10 micro backend AI models, which support many AI models like Omni, like Llama, like Cybertron, and so on. And we are planning to have an integration with other tools like sandboxes and so on. And what we are planned for is an interactive chatbot. So if you see here, we are using an AI as a backend to do the analysis job, but we are planning to have an interactive chatbot. Like, I don't have to analyze the whole file. I just have to go and start talking with BinaryGPT and asking him, is there any kind of persistence in this malware? And he will respond to me. Is there any encryption key? Is it ransomware? Yes, it is ransomware. What is the encryption key? What is the encryption algorithm? This is what we are planning to do out of all of this. This is in a stage right now. We are working on it. Hopefully, by the end of 2024, we can have it ready. And to wrap up, BinaryGPT will not replace any malware analysis, okay? Because malware analysis is a tough job, and malware authors are using too many advanced techniques, and we have to keep ahead of them. Plus, we have seen threat actors are using AI to generate new malwares, okay? And recently, I have noticed some of them are using anti-AI analysis techniques to make our life more difficult. So what we are planning to fight AI with AI. If they are using AI for malware generation, we are using AI for malware analysis as well. And this is the value of BinaryGPT. I hope you enjoyed the session. If you have any question, just let me know. Thank you so much.
All right. Thank you, Ahmed, for that insightful,
I believe this
presentation.
photo is generated by AI.
It's very good, actually. I could use it in the
Yeah.
future.